Hi, I'm Oni, and I'm part of two IIT alumni who post daily videos on math and physics on our YouTube channel, Mathophy. Let's get started with our JEE problem. So today, continuing over from the previous day, we'll be continuing with alternating current. Today we'll be doing a slightly advanced sums. Some of them have appeared in IIT JEE in the previous years, so we'll also be doing those sums. So the first question says that when an alternating current, alternating voltage V equal to V naught sine 100t is applied across a circuit, then the phase difference between voltage V and the current I in the circuit is pi by 4. If the circuit consists of only R and C in series, then the relationship between the two elements is. So we know that first thing we need to observe is this phase difference over here. Now we know for the formula for phase difference in an AC circuit is given by tan phi is equal to, if there is only an R and C, then tan phi is given as 1 by omega C divided by R. The actual formula is 1 by omega C minus omega L by R. Since there is no inductance, so it is just 1 by omega C divided by R. So now we just put the values in of 1 by omega C and R. Omega over here is 100 because this formula should be sine of omega t. So we put the value of omega as 100 and we get 1 by 100C divided by R. Tan phi is given as pi by 4, so tan pi by 4 is equal to 1 by 100 C into R. Or tan pi by 4, we know tan 45 is 1, so 1 is equal to this, so CR is equal to 1 divided by 100. Now there are 4 combinations given here. We need to find out that combination where C and R when multiplied give me 1 by 100 factor. So let's look at the first one. R is 1 kilo ohm, so 1000 into 10 microfarad. So for the first option, CR is equal to 10 to the power 3 into 10 into 10 to the power minus 6. So if we do that, we have 10 to the power 4 and 10 to the power minus 6, so 10 to the power minus 2. So with our first option only, we got this as correct. We don't need to move to the other ones because we know this is a single option correct. So our correct option is option number 1. Let's move ahead to the next sum. So the next question is a question that appeared in IIT 2010. The question says that an AC voltage of source of variable angular frequency omega and a fixed amplitude V naught is connected in series with a capacitance C and an electric bulb of resistance R. So it is just an RC circuit. The inductance has been given as 0. It says that when the omega is increased, that is the angular frequency is increased, and which of these become true. Now we need to see that firstly we need to find there are two things that it checks, that whether the bulb glows brighter or dimmer and whether the total impedance is increased or it remains unchanged. So we need to look for two quantities. One is the impedance and the other is the current, because the current will define whether the bulb glows brighter or dimmer. First, finding the impedance. In an RC circuit, the impedance, it's a direct formula, we all know. The impedance Z is given by R square plus 1 by omega C whole square. So if we just put the value of omega as increased, if omega goes up here, this quantity as a whole goes down. So if this is called the capacitive reactance, if omega increases, capacitive reactance goes down, and hence the overall impedance goes down. So it does not increase, it does not remain unchanged, the impedance as a whole goes down. Now let's see what it does for the current. The current through a resistor is simple. I naught is given by V naught by Z. V naught is a constant fixed amplitude. So we only check what happens to Z. So we found out over here that Z decreases. So if Z decreases, if the denominator decreases, then the current goes up. If the denominator is decreasing, the fraction value goes up. So I naught increases. Now whether to check whether the bulb glows brighter or dimmer, so we need to check for the power. The power is just I square into R. R is a constant, so it just depends on I. So if I is increasing, then the power itself also goes up, so the bulb tends to glow brighter. Let's move ahead to the next sum. So the next sum is also another sum that has appeared in IIT. This time it appeared in IIT 2011. It says that a series RC circuit is connected to an AC voltage source. Consider the two cases when C is without a dielectric medium, and next is when C is filled with a dielectric of constant 4. The current IR through the resistor and voltage VC across the capacitor are compared in the two cases. Which of the following are true? So here we can either go with the formulas, or we can directly use some of the principles which we have covered in our previous videos. Firstly, to check for the voltage across a capacitor, this we can directly define that the voltage in a capacitor goes down as the dielectric constant goes up. So in the first case, dielectric constant is, there's no dielectric, so dielectric constant is 1. In the next case, dielectric constant is 4. We know, if we can just check the formula for voltage, we have 1 by 4 pi epsilon naught Q by R. This is a general formula for voltage. So we know if there's a dielectric constant K, you replace epsilon naught by K epsilon naught. So by that logic, if K goes up, the denominator goes up, so V as a whole goes down. So we know from the very beginning that in the second case, the voltage across the capacitor will be less than the voltage in case when there's no dielectric. So we know that VB will be less than VA. So this option is correct. But this is a multiple option correct because they have asked it whether is or are true. So we know there may be more than one option correct. So we'll check the other options. The other options ask for the current across the resistor. Once again, following from the previous sum, the current across the resistor is just V0 divided by Z. V0 here is not capacitive voltage. V0 is the source voltage, which remains constant. So V0 divided by root over of R square plus 1 by omega C whole square. Now just like when the dielectric constant goes up, voltage goes down. Similarly, we also know that the capacitance goes up. So dielectric constants and capacitance are directly proportional. So in the second case, as the dielectric constant goes up, the capacitance goes up. Capacitance goes up means this quantity goes down. So XL, this quantity is XL, this goes down. This quantity as a whole is Z. Z eventually will also go down because the additive term is going down. And again, since the denominator goes down, the whole fraction goes up, so the current rises up. To summarize the entire thing, K goes up, so C goes up. Since C goes up, XL goes down because it is inversely proportional to C. The impedance Z goes down because an additive term to XL. Because Z goes down, it's inversely proportional to I, so the current goes up. So we know in the second case, when K value is higher, the current is also higher. So IB is greater than IA. So correct option is option number 2. So this has two correct options, number 2 and number 3. Next day we'll be doing electromagnetic induction and more sums on that. So look ahead to the next video. I'll see you again next day. Like, comment and subscribe to our YouTube channel Mathophy for your daily dose of math and physics.